Okay, final example. Y equals negative x squared minus 5x minus 8. Is that the same equation you have?
Yeah.
I'm questioning because my 5's bigger than the 8. I think it looks like I might have overtyped it or something. Makes me feel better. Okay, great. I think I might have had the wrong problem up there at one point in time. All right, so I see negative x squared, so I'm already assuming my graph's going to look something like that. So again, right off the bat, before I do anything, I already know what my answer is going to look like. I don't know where it's at. Not sure exactly where on the graph it's going to be, but it's going to be a downward turning parabola. If we do, the x value of the vertex is going to be the opposite of b, which will be positive 5 over 2a. That's 2 times negative 1. That gets me negative 2.5. So here's the situation I was just getting at in the last problem. What if you get a non-integer from the vertex? You have to plot the vertex. The lowest point, or the highest point in this case, of a parabola needs to be graphed every time. The other points are up to you. Okay? I would pick negative 3 and negative 4 going smaller, negative 2 and negative 1 going bigger. And again, it's important that you realize x squared is a positive value no matter what x is. So we got a bunch of negative values here for x. When I square it, I get a positive, but then the minus changes it back to negative. And I do get a lot of people getting wrong results because of that type of stuff happening. They'll write it down, y equals minus negative 4 squared minus 5 times negative 4 minus 8. They'll write it down like that. They see a minus minus and then something in their brain goes, oh, that's plus. Every time that's a plus. And it's not. So my recommendation is this. Rather than writing it out like that, square things in your head. So we know y is equal to negative something, right? Negative 4 squared is 16. Okay, you square it in your head, you put a minus sign in front of the squared object. So that way you're not visually seeing minus, parentheses, minus, and thinking that means plus. You're squaring the negative 4 in your head, positive 16, then the minus sign occurs after that. Then minus 5 times negative 4 is going to be plus 20, and then minus 8. Okay, so if you go ahead and evaluate some of the stuff in your head, it makes the evaluation easier. Negative 16 plus 20 is 4, minus 8 is negative 4. All right, we try negative 3. I got minus 3 squared is 9. Minus 5 and minus 3 make plus 15, minus 8. Minus 9, minus 8 make minus 17, plus 15 is minus 2. Two and a half squared is 6.25. Minus 5 times minus 2.5 is plus 12.5. Negative 6.25 plus 12.5 is 6.25 minus 8 is 1.7, negative 1.75. All right. The next number should end up being negative 2, right? Again, we should expect the symmetry because I'm exactly half away. I'm exactly half away, the same distance away on both sides. So I should expect to get negative 2, but I want to verify it. So y equals negative, that'll be 4. Minus 2 and minus 5 make plus 10, minus 8. Negative 12 plus 10 makes negative 2. Symmetry occurred, so I can be assured that's going to be symmetrical too. And once you get that symmetry, you know the opposite side. So I plot my 5 points. Negative 4, negative 4. Negative 3, negative 2. Negative 2.5, negative 1.75. You just kind of ballpark that one. About halfway across and a quarter of the way up from there. So 1 3/4 down. Negative 2, and negative 1, negative 4. Okay. The points got a little bit more compacted because we had that half difference between the first two, but we still got parabolic shape. Notice right here, there's my parabola happening, and it just continues on down like so. My axis of symmetry on this one is going to be x equals negative 2.5, and its graph is simply going to be a vertical line through the vertex. So all three of those problems, the same technique was used every single time. There's another technique the book likes to use that involves completing the square. I'd like to avoid that one for now. Get into geotrig and you decide to take on that challenge, we'll deal with the completing the square technique there. This one's a little bit more basic, easy to do. Most people can catch on pretty quickly and get good at these. I can pick any values for x. So even if I forget this formula, let's say I'm on a test, okay, and I forget this formula. Was it negative b over 2a or negative a over 2b? I can't remember. So if you can't remember that, just pick a bunch of random x's, plot the points, and you should be able to find the bottom, okay, or the top. All right? If it happens to be like this, or if you can find the symmetry happening with your integer values, you know it's halfway between, you know, you get these, then you can figure it out there. So keep that in mind. If you can find the symmetry, you can find out where the vertex should be. But that's how they work. Use the formula. That allows you to pick the x's, substitute the x's to get the y's, plot the points, and axis symmetry is x equals whatever that number is.